In this video, you're going to learn how to simplify radical expressions, and we're going to go through 10 examples together. So try some of these on your own, pause the video, and we'll go through them all together. Let's dive into the first example here. We've got 6 square root of 12 minus 3 square root of 3. We want to combine these or simplify them as much as possible. So the first thing I want to do is I want to look at, are there perfect squares that I can divide out of 12? Or another option is you can do a prime factorization tree. You could say, well, what is 12 made up of? Well, it's made up of 6 times 2 is 12, and then 6 is 2 times 3. And so what I did is I broke this down into the prime factors. When you're looking for a square root, you look for 2 of the same number. If it's a cube root, you look for 3 of the same number, 4th root 4 of the same number. So here you can see this is really like 2 squared, because 2 times 2, and the square root of 2 squared is just 2. Now what happens is that 2 comes out in front of the square root, okay? And what we're left with is just this square root of 3. That's kind of like the remainder. We can't divide out another perfect square out of 3. It's a prime number. But you see this 2 that came out in front? And notice this 6 is right next to that square root, right? So that means that it's going to be multiplied by this quantity here. So we're going to be multiplying the 6 and the 2 together, the two integers, and that's going to give us 12 square root of 3. Bringing this down, minus 3 square root of 3, we have the same type of radical here, square root of 3. So it's like I have 12 of this quantity minus 3 of the same quantity gives us 9 square roots of 3. It's kind of like if you had 12x minus 3x, you'd say 9x. So you're just combining the coefficients or the numbers in front of that radical. So let's look at example number 2 now. We've got negative square root of 150 plus 4 square root of 24. Now you can see these two quantities underneath the square root are not the same like they were over here, so we can't just go right into simplifying. What we want to do is we want to simplify what's underneath that square root first and then take it from there. So square root of 150, now I know that there's a perfect square that goes into 150, 25, because I know that 25 times 6 is equal to 150. So you can try to divide out perfect squares like 4, 9, 16, 25, 36, etc. Or you can do the factor tree method that I was showing you over here. Now 25, that's square root of 25 is 5, because 5 times 5 is 25, so that's going to give us negative 5 square root of 6. Over here now 24, I know that that's going to be the same thing as 4 times 6. Square root of 4 is a perfect square. That's going to be 2. But you see how the 4 is right next to that square root? Again, that means multiplication. So this is going to come out to 2 times this 4 is going to be 8 square root of 6. So now you can see we have negative 5 square roots of 6 plus 8 square root of 6. How many square roots of 6 do we have? 3 square roots of 6. And that's as far as we can go. So you want to try to simplify as much as you can first, and then if these radicals here are the same, you can add or subtract the coefficients. So that's the key. Now with number 3, a little bit more challenging because we're dealing with a cube root. Okay, this is what's called the index here. Okay, the 3. If it's not written, that's like understood to be a 2. That's the square root. So over here, the cube root of 32, we're looking for perfect cubes. Now remember, the perfect cubes are like 8, because that's 2 times 2 times 2, or 27, that's 3 times 3 times 3, or 64, that's 4 times 4 times 4, or 125, that's 5 cubed. It's good to know those or memorize those, but a lot of students, they just like to break it down. And I like this method because, especially when it's a larger number, you can just see what that number is made up of, like what the components are, you know. So if I multiply all the ends of the branches here, 2 times 2 times 2 times 2 times 2, that's going to give me back the 32. But when I'm taking the cube root, I look for 3 of the same number, because that's like 2 to the 3rd power, or 2 cubed, and the cube root of 2 cubed is just going to give us 2. They're inverses, they undo each other. Now this 2, it comes out in front of the radical there, but it's multiplied by that 7, because they're side by side with nothing in between, right? That means multiplication. So we've got 7 times 2, which is 14, cube root of 2 times 2, that's what's left over, that's 4. So whatever is left, you're going to multiply that together, that stays underneath. That's kind of like the remainder. Now over here, 108, let's do the same thing. 108 is 2 times 54, and 54 is 2 times 27, and 27 is 9 times 3, and 9 is 3 times 3. So again, we're looking for groups of 3 since it's a cube root. So here's 3 of the same numbers. That's going to come out to 3 cubed. The 3 cubed and the cube root of 3 cubed is just 3. And that 3, when it comes out in front, it's going to be multiplied by this 2. So this is going to be negative 6 cube root of 2 times 2, which is 4. Now look at what we have here. We have 14 cube roots of 4 minus 6 cube roots of 4 is 8 cube roots of 4. And that's as far as we can simplify it. So let's take a look at some more examples. If you're starting to get the hang of this, see if you can do some of these problems on your own. So let's dive into number 4, and what makes this a little bit more challenging is now we're introducing some variables into these radical expressions. So for number 4, let's start with the square root here, 18m cubed, and again, let's break this down. So we can think of this as 18 is 9 times 2, and 9 we know is 3 times 3, and then m cubed is like 3 m's multiplied together, right? But when you're taking the square root, you're looking for 2 of the same number. That's a perfect square. So here we have 3 times 3, that's 3 squared, or 9. The square root of 9 we know is 3. That 3 is going to come out in front of the radical. It's going to be multiplied by this 5m. Also notice we've got m cubed, which is like 3m's. Again, we're looking for groups of 2. This is going to come out in front. So the square root of m squared is just m times this m. And what we're left with is this 2 and this m's. So let's go ahead and do that again. So we've got 3 times 5, which is 15. M times m, which is m squared, and then what we're left with is the square root of 2m. Over here, same thing, we've got 8, which is 4 times 2, and 4 is 2 times 2, and then m to the 5th we know is like 5m's multiplied together, right? But again, we're looking for groups of 2 of the same number. So this is like 2 squared, the square root of 2 squared is 2, times this negative 4 would give us negative 8. And then here's a little trick or technique that you might want to utilize. Remember, when there's not a number here or an index, it's understood to be a 2. And what I like to do is I say, how many times does 2 go into 5? 2 goes into 5 twice, so that's going to be m squared with 1 left over. So that's going to be left with 1m here. We're also left with this 2, that's 2m. So the reason that works is because, you know, m to the 5th is like 5m's. Let's draw this out here. We're looking for groups of 2, so that's m times m, which is m squared, with 1m left over, see? So now what we can see is we've got the same quantity here. We have m squared, square root of 2m, m squared, square root of 2m. I've got 15 of this group minus 8 of this group. 15 minus 8 we know is 7 m squared, square root of 2m. And that's your final result. Okay, let's look at number 5 now. We've got the square root of 160 minus 3 square root of 54 plus 2 square root of 360. So what makes this more challenging is we've got 3 terms or 3 groups. So let's go ahead and tackle this one. So again, I like that prime factorization method, just breaking it down. 16 times 10 is 160. 16 is 4 times 4, and 10 is 2 times 5, and of course 4 is 2 times 2. So breaking it down now, just using the ends of the branches, not these numbers higher up, just the ones at the very end, we want to look for groups of 2 of the same quantity or the same number. So we've got, here's a group, a 2 and a 5 left over. So this represents 2 times 2, which is 4, square root of 10. Okay. Again, if you forget, just go back to the basics. You say, well, this is like 4. What's the square root of 4? It's 2. This is 4. What's the square root of 4? That's 2. And then 2 times 2 is 4. So you want to make sure that it makes sense to you. You don't want to just follow kind of like a pattern blindly, right? So over here now, 54, this is 9 times 6. 9 is 3 times 3, and 6 is 3 times 2. Now, if it was a cube root, I look for 3 of the same number. This is a square root, so we're just looking for 2 of the same number. So we've got 3 times this 3, and so this comes out to negative or minus 9 square root of 3 times 2, which is 6. Now notice these square roots are different, so we're not going to be able to combine those. But let's take a look at this third expression here. 360, we know that's 36 times 10, and 36 is 6 times 6, and 10 is 2 times 5. Now you could keep breaking down the 6's. into 2 times 3, but I might want to just stop here and say, well, I've got a group of 2 of the same number, and that's what I'm looking for when I take the square root. So I'm just going to call this 6 times this 2, which is going to give me 12 with the square root of 2 times 5, which is 10 left over. Now notice these two groups are the same, right? I've got 4 square root of 10 plus 12 square root of 10. That's 16 square root of 10 minus 9 square root of 6. Now you don't want to make the mistake of saying, oh, 16 minus 9 is 7, square root of 10 minus square root of 6 is 4, something like that. You really can't combine it. It's almost like saying 16y minus 9x. You wouldn't combine those because you'd say, oh, they're different variables or different terms, right? So in this case, this is as far as we can go with this problem. Okay, let's look at number 6 now. We've got some more variables here, and these are cube roots. See the 3, the index? So how would you tackle that one? See if you can do this problem. Well, I'm going to go back to my trusty prime factorization method. So 9 times 6, 9 is 3 times 3, and 6 is 3 times 2. Now, cube root, I'm looking for groups of 3 of the same number. It doesn't have to be the number 3, just 3 of the same number. Because remember, this is really like 3 cubed, and the cube root of 3 cubed, see, those are inverses. They undo each other, so you're just getting 3. Okay, and that 3 is going to come out and be multiplied by this 7. See how these are right next to each other? So this is going to be 21. Now, x to the 4th, that's like 4 x's multiplied together. You can see that there's one group of 3 there, so that x is going to come out in front. It's going to get multiplied by this x, giving us x squared. And then we're left with this 2 here and 1x here, so this is going to be the cube root of 2x. Now there's a lot going on there, right? And you might want to initially try to write out all these x's. Sometimes that's a good way to go. Like I could say 1, 2, 3, 4 x's, looking for groups of 3. So this would just be x that comes out, gets multiplied by this x squared, with 1x left over. So we had a 2 and an x left over. That stays underneath the radical, right? Okay, going over to this group here now, 16x is, now again, when you get a little bit better at this, you can get a little bit quicker is what I mean. And the 16 is like 2 to the 4th, and this is like x to the 1st. Now when I have an exponent, okay, a power, right? What I like to do as a shortcut is I like to say, how many times does 3 go into 4? That's once, so that means I have 1, 2 that's coming out here with 1, 2 left over. So that 2 that comes out is going to get multiplied by this 8. So this is going to give us negative 16 x squared. There was a 2 left over and an x left over. That's going to stay underneath the radical. So do you follow that? Okay, if you don't, write it out. So 2 times 2 times 2 times 2, x to the 1st. Looking for groups of 3, that's like 2 to the 3rd power. The cube root of 2 to the 3rd power is 2, times negative 8 is negative 16, x squared. We're left with 2 and x. That's kind of like a remainder. We don't have enough to make another perfect cube root, right? Okay, now let's analyze this. We've got x squared cube root of 2x, another x squared cube root of 2x. The coefficient or the number in front tells us how many of that group that we have, right? We've got 21 of these minus 16 of the same group or chunk, right? Sometimes people call this chunking. 21 minus 16 gives us 5x squared cube root of 2x. See, 5 of that quantity, 5 of that group left. And that's your final result. So let's take a look at a few more examples. Okay, see if you can do number 7 and number 8. So for number 7, we've got 3 radicals here that we're trying to simplify and combine if possible. And again, we want to think about pulling out perfect squares, right? So 192, we know that's 96 times 2. Whenever it ends in an even number like 0, 2, 4, 6, or 8, you can cut it in half. And then again, see, this is an even number, so I kind of just keep cutting it in half as long as it's even. That's a good way to kind of break it down until you get down to smaller numbers that you're maybe more kind of familiar with. That's kind of a good strategy. And then we're looking for groups of 2 of the same number since we're taking the square root. See, there's not an index. So we've got 2, we've got 2, we've got 2, and we have a 3 left over. So this is 2 times 2 times 2, which is 8. Square root of 3. Now, one way you can check your work is you could say 8 squared is 64 times 3 gives us back the 192. So you square this number on the outside, multiply by what's on the inside. That's a way to kind of check your work. And over here, square root of 125. Now this one, it's jumps out at me that this is 25 times 5 is 125, because there's 5 quarters and $1.25. And the square root of 25 is 5 times this 4 is 20. So that gives us 20 times the square root of 5. And then over here, square root of 60, this one we can write this as square root of 4 times square root of 15. 15 is just 3 times 5. There's not a perfect square there. Square root of 4 is 2 times this 3 is 6. So this would be minus 6 square root of 15. Now notice here that these quantities underneath the square root, none of them are the same. So we can't combine any of these terms together. This is actually as far as we can go on this problem. Okay, let's look at number 8 now. So some more square roots we're working with. See if you can simplify this one. Now 153, you could break this down into 51 times 3, and 51 is like 17 times 3. And here's a pair of the same number. We've got 3 squared. The square root of 3 squared is just 3 times negative 2 gives us negative 6 square root of 17. Over here, 68, this is an even number, so I can divide this by 2. So that's 34 times 2. 2 times 17 is 34, and then there's a pair of 2s, so that's 2 times negative 2 is negative 4 with a 17 left over. 17 is prime. Now this is nice because we've got the same square root here. We've got negative 6 of these minus 4 of these is negative 10 of that same quantity. So negative 10 square root of 17. Let's take a look at 2 more examples together. Okay, see if you can do number 9 and number 10. So number 9, we've got some cube roots and some variables. Number 10, we've got a square root and a cube root in the same problem. So go ahead and do those. And while you're doing these problems, I want to let you know about 2 of my video courses that I have for sale. One is in Algebra 1, and the other one's in Algebra 2/College Algebra. So if you like the way that I explain things, but you want to go deeper and you want to kind of learn sequentially, building upon previous concepts so that you can really master those courses, check out those video courses. One has 85 lessons, the other one has 87 lessons, and they're very comprehensive with practice, going over the concepts together. I give you some examples that you can do on your own as well, and we go through those. So there's a lot of information that's in those courses, so check those out. And then another thing I want to let you know about is that now you're able to join Mario's Math Tutoring as a channel member. And if you join at the additional videos level, you can get access to now over 120 videos on that additional videos members section. So I've got things like my geometry course on there. I've got midterm and final exam reviews, and I've got my ACT and SAT courses on there as well. So lots of material there, lots of videos that you can check out if you want to go deeper. So let's dive into the last examples here, and then we'll finish off this video. Number 9, we've got 6y times the cube root of 128y. So what we're going to do is we're going to break down this 128 into 64 times 2, and 64 is 8 times 8. And I know 8 is 4 times 2, and 4 is 2 times 2. So this is like 3 2s. This is also like 3 2s. And I'm looking for groups of 3, so I have a group of 3, a group of 3, and a 2 left over. So this is going to be 2 times 2 is 4. Times 6 is 24, y with a 2 and a y left over. So I didn't have enough to make another group of 3. That stays underneath. That's kind of like the leftover of the remainder. Over here with the 250, I can see that this is 125 times 2, and 125 I know is actually 5 cubed. And the cube and the cube root, those are inverses. They undo each other. That's just going to give us 5 times this 5 is 25. Now y to the 4, 3 goes into 4 once, so that comes out in front with 1y left over. This 2 is also left over, so that's going to leave us with the cube root of 2y. Now look at what we have here. We've got this y cube root of 2y, y cube root of 2y. I've got 24 of these plus 25 of these. That's 49y cube root of 2y's. Okay. So they're combining like terms, but this quantity has to be the same in order to add or subtract the coefficients. Okay, last problem, number 10. We've got some really large numbers here. What can we do? Well, let's break it down. We've got 44,100. That's really like 441 times 100, right? 2 zeros, that's times 100. 441, now here's a little trick you can do. when you add up the digits, 4 plus 4 plus 1, that's 9. If the sum of the digits is divisible by 9, the whole number is divisible by 9. And so that comes out to 9 times 49. And then 49 we know is 7 times 7, 9 is 3 times 3, and 100 is 10 times 10. So look what we've got. We've got a pair of 10s, a pair of 3s, a pair of 7s. So that's going to be 7 times 3 is 21, times 10 is 210. That's the square root of 44,100. Minus, now the cube root. So the cube root of 27,000 is 27 times 1,000. Cube root of 27 is 3. Cube root of 1,000 is 10, because 10 times 10 times 10, and 3 times 10 is 30. So we have 210 minus 30 is 180, and you got it. So great job if you're able to follow these 10 examples. If you want more practice learning more about radicals, I'll put another video that's good for you to watch and practice with right there in that video there. Follow me over that video. We'll get some more practice. I'll see you over there.